Okay. Uh, can you hear me?
Yeah.
Okay. So we'll be starting this permutations and combinations. So basically, this is the theory of counting. Basically, so how to count in certain cases when obviously a physical count is not possible. So you have to understand a
Mm.
ways to find out the total number of ways in which certain thing can happen when physically counting them is not feasible, right?
Yeah.
Yeah.
So we will start off by looking at how many ways how many ways we can select some things. How many ways to select? Ways to select. So here the main distinction that you should be aware of is that combinations is basically selection. How many ways to select? And permutation is an arrangement. How many ways to arrange? So basically, if I have some many letters, right? A, B, C, D till X, Y, Z, right?
Yeah.
Now, now you can say how many ways are there to select any 5 letters out of them, right?
Yeah.
So that is a combination question, right? That is a selection problem. Like which
Mm.
5 letters can I select? I can select A, B, C, D, E. I can select B, C, D, E, F, right?
Yeah.
To
Yeah.
select any arbitrary combination of 5 letters, right?
Yeah.
So there are many ways in which I can select 5 letters, right?
Yeah.
So that will
Yeah.
be given by how many total letters are there? 26, right? And
Mm.
how to select
Mm.
5 from them? 26C5,
65. Yeah.
right? So these are the total number of ways in which you can select 5 letters out of the 26 letters, correct?
Mm. Yeah.
So if
Yeah.
you do the calculation of that, that will come out to be 26 factorial by 21 factorial into 5 factorial.
5 factor.
So this will be 26 into 25 into 24 into 23 into 21, 2 into 21 factorial gets cancelled,
Yeah. Like
divided
that.
by 120, right?
Yeah.
So this becomes 12 twos are and 12 tens are, and this is 5, and this becomes 5, and you have this calculation. This thing is the answer. These are so many ways to select 5 letters from them, right?
Mm. Mm.
So
Yeah.
that is a selection problem. However, we could also have said that after the selection, find out find out number of ways in which you can arrange the 5 letters in a row.
Mm.
Number
Mm.
of ways to arrange the 5 letters that you selected, the 5 letters in a row, right?
Yeah.
So now it is about an arrangement, right? So the
Yeah.
selection part is already done, and you have your set of 5 letters, right?
Mm.
So let's
Yeah.
say the set that you had selected was A, D, B, Z, P, right? These were the 5 letters selected, right?
Yeah.
Yeah.
Now, obviously, this is not a unique 5 letter selection, right? There are actually so many possible such selections, right?
Mm. Yeah.
Mm.
Correct.
Yeah. Yeah.
Yeah.
But for each such selection, how many ways can you arrange them, right? You can arrange them in a row
Different. Different.
by taking 5 spots here, right?
Yeah.
And
Yeah.
saying
Yeah.
first spot can be filled in how many ways? 5 ways.
5 days.
Yeah. Five
Second
ways.
spot can be filled in 4 ways,
Four.
4 ways.
Three.
Yeah.
3 ways,
Two.
and 2 ways, and last spot only one is left, right?
Yeah. Yeah.
So there are
Yeah.
five
Yeah.
factorial ways, no?
Yeah.
So total number of ways to do the whole arrangement will be 5 into 4 into 3
Four into.
into 2
Yeah.
into 1, which is 5 factorial ways to arrange, right?
Yeah.
Correct. So
Yeah.
for
Yeah.
each selection, there are 5 factorial additional ways to arrange them, right?
Yeah.
Mm. Yeah.
Correct. So this is an arrangement problem. This is a permutation, and this is a combination where you select, right?
Mm. Yeah.
You
Yeah.
need to understand the difference between the two. It is very clear, right? One is
Yeah.
taking out some. Which ones will you take, right? And other is order will matter and how to arrange them, right?
Yeah.
Correct. And if I had given you the question saying how many ways to find out the number of ways, find out number of ways to pick out 5 letters from the alphabet and arrange them in a row.
Mm.
on the alphabet and arrange them in a row. So every arrangement is obviously different, right?
Yeah.
Yeah.
Even though you picked the same 5 letters, then also the arrangement is different, then it is counted as different, right?
Yeah. Yeah.
Yeah.
Then obviously this question involves first selecting and then arranging, right?
Yeah. Yeah.
Mm.
First select, then arrange, right? So
Yeah.
selecting 5 letters could have been done in 26C5 ways, right? And
Yeah. And
arranging
then
each
five.
of those could have been done in 5 ways, right?
Yeah.
So the multiplication should be the total number of ways to do this, right?
Yeah. Yeah.
So that will
Yeah.
become 26 factorial by 5 factorial, 21 factorial into 5 factorial, which becomes 26 factorial by 5 factorial. And this is basically n factorial by n minus r factorial, right?
Hmm. Hmm.
This is
Yeah.
sometimes given the symbol of npr, or just like this was called ncr, right?
Yeah.
This is called npr, number of ways to pick and arrange them, right? Number of
Hmm.
ways to take any 5
Sir,
out of a set.
like, isn't it 26 factorial divided by 21 factorial? Because 5 factorial got cancelled, right?
Oh yeah, it is 21 factorial.
21.
N factorial by n minus r, that makes sense, right?
Yeah.
Yeah.
Because r was 5, right? So 26 by 21, right? So
Yeah.
that
Yeah.
is the NPR definition. So select 5 out of the 26 and then arrange them. That number can be directly written as NPR, right?
Hmm.
Yeah.
So how many ways to arrange 5 things out of 20, n things? Or arrange r things out of n things will be NPR, right? Basically, that
Yeah.
is equal to NCR into r factorial. You
Yeah.
understand the
Yeah.
logic of it? First select the r, then arrange them.
Yeah. Yeah.
Okay, so right now we'll first begin with selection problems, and once we are done with selection, then we'll go on to other type of things, right? So selection basically means combinations, right?
Yeah.
Correct. So the first point is that number of ways of selecting are things from n things, are things from n different things. Now here obviously this different and all and same matters, okay?
Yeah.
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 And distinct things.
Yeah.
This is going to be different when uh, and if it was n identical things, that would have been different, okay?
Yeah.
Because if it is n identical things, suppose there are a's, right?
Yeah.
So suppose 26 a's are there, right? How many
Hmm.
ways of selecting 5 a's out of this, right? Only one way.
One. Yeah.
However, if there are distinct
Hmm.
letters, right? The number of ways of doing this was 26C5, right?
Yeah.
You understand that clearly this matters a lot, right?
Yeah. Yeah.
So when it
Yeah.
is R things from N different things, the number of ways is NCR,
Hmm.
right?
Yeah.
If it was R things from N identical things, then obviously that is only one way.
Hmm.
You just have to count whether you took the right number of things, right?
Yeah.
Yeah.
You
Yeah.
don't have to, actually, you cannot distinguish between 5 uh, and any other 5, right? That is the same, right?
Yeah.
You understand? I could
Yeah.
have picked this 5, right? But that is not going to be different from this and some other 5s, right?
Yeah.
If the
Yeah.
things were identical, right?
Hmm.
So therefore, it is important to notice these
Yeah.
words and all. It is super important. Otherwise, you'll not understand. So whenever there things are distinct or things are identical, it is different cases, right?
Hmm.
So
Yeah. Yeah.
Yeah.
let's look at another example where number of ways of selecting number of ways of selecting are things from n n distinct n distinct things and distinct things if one particular thing is always included in your selection, right?
Yeah.
Always included in your selection. So basically this is like saying I have to select 5 letters from ABCD, but
But
B
A
should
has to
also
be.
be,
Yeah.
always be there,
Hmm.
right? So if B is always
Yeah.
there, so that boils down to basically selecting 4 things from
4 from
25,
25. Yeah.
right?
Yeah.
It makes
Yeah.
sense, right? B always has to be there, so we don't have to worry about B. So there are remaining 25 letters and you have to select 4, right?
Yeah.
Yeah.
So this will be basically one thing is already there, so n minus 1 C R minus 1, right?
Yeah. Yeah.
Yeah. Yeah.
Correct. And what is the value of n minus 1 C R minus 1? It will be n minus 1 factorial by do R minus 1 factorial multiplied by n minus 1 minus R plus 1 factorial, right?
Yeah. Yeah.
Yeah. Yeah.
That becomes n minus 1 factorial by R minus 1 factorial into n minus R factorial, right?
Yeah.
Yeah.
Correct. I mean, hopefully the calculations are correct. N minus, it's correct only,
Yeah.
right? Okay. So, uh, okay. Then we move on to a case where, let's look at an example, for example. So let's see how many ways how many ways can A call four out of his call 10 friends if B and C, two friends, if B and C are always included, right?
Yeah.
So B and C are
Yeah.
always there. So technically you have to call how many friends left? Two, right?
Yeah. Yeah.
From 8, right?
Yeah. Two
8
friends. Yeah.
2.
Yeah.
So it should be 8C2.
Yeah.
Similar question can be given if this person you are not going to call, right? If one
Hmm.
person is always
Yeah.
excluded,
Yeah.
then you will have to call
Yeah. Yeah.
4 people from the remaining 9 only, right?
And
So suppose in the same question it was like some D person he's not going to call, right?
but
So how many ways to do that would have been out of 9 he has to select 4, right?
yeah, in this case the R
Yeah.
wants
Yeah.
to be.
Correct. So it is obvious what to do in these cases as long as you understand the meaning of selection, right?
Yeah.
Now, how many how many okay. Okay, so suppose there are n different things are there, okay, are present, and how many ways are there? How many ways are there to select one or more than one things out of these n things, right? How many ways are there to select one or more than one out of these n things? That is the question. So what are the options for the person? He has to select, he can select one, he can select two, he can select how many? Maximum how many?
Yeah.
He can select all of them,
And
right?
Yeah.
yeah.
So if he selects one, how many ways are there?
And C1.
NC1.
Yeah.
And if
Yeah.
he
Yeah.
selects two, how many ways are there?
C2.
and so on.
Yeah.
Yeah.
And if we select n, how many ways are there? NCN, right?
NC1.
Yeah.
Now the problem is here that you have to select one or more, right? So these are or choices, right?
Yeah.
So
Yeah.
so
Mm.
here we come across the one important principle that is called there are two things. There's one is called the addition principle and one is called the multiplication principle. Okay.
Mhm.
So
Yeah.
what I mean by these two is that if there is a question where you are saying either this or this, right? You can do
Yeah.
either A or B, right?
Yeah.
Suppose you can do A in 3 ways or B in 2 ways, then obviously total number of ways that you can do something is A or B is 3 plus 2, right?
3 plus 2. Yeah.
So
Yeah.
whenever it is or, it is addition principle,
Addition.
right?
Yeah.
Because you can do either
Yeah.
this or that, right?
Mm.
However, suppose you have to do a task at any, and it involves doing two separate subtasks, right?
Yeah.
The subtask has to be done, only then can the whole task be accomplished, right?
Yeah. Yeah.
Yeah.
Suppose you have to do an assignment and part one of the assignment is something and part two is something else. Part one can be done in 5 ways and part two can be done in 3 ways, right?
3 ways. Yeah.
So total number of unique ways of doing the assignment would be 5 into 3, right?
Yeah.
Because
Yes.
for
Yeah.
each way of part one, you have 3 other choices for part two.
Part 2. Yeah.
Correct.
Yeah.
So when you have an and question, right? When this has to be done and this has to be done, right? Then
Yeah.
number of ways of doing first thing multiplied by number of ways of doing second thing, right?
Yeah.
Correct.
Yeah.
Here, however, it is an or question, right? You can select one or more, but you cannot select one and two, right? That doesn't make any sense, no?
Yeah.
What makes sense is one or two or three, whatever. You have to pick
Yeah.
one, right?
Yeah. Yeah.
So here, this is an addition problem, right?
Yeah.
So just remember the main rule that or means addition, right? Because obviously you have a choice. You can do either or this, right?
Yeah.
Yeah.
And means basically the task has been broken down into subtasks and each has to be completed. Only then the whole thing can be done, right?
Yeah.
And if the subtask
Yeah.
can be done in individual number of ways, then the total task can be done in product of those ways, right?
Yeah.
Yeah.
So the question is basically just this much. This is
Yeah.
the answer here.
Yeah.
And this you know from binomial
2 to the
theorem
power
will be
n.
2 power n minus 1, right?
Yeah.
Because NC0 was not included, no?
Yeah.
Yeah.
Correct. If there was C0
Yeah.
plus C1 plus Cn, right? Then it would have been 2
Yeah.
power n, right?
Yeah.
You could also have thought about this question in a different way. You could have said that number of ways there are to select one or more things out of these n things will be equal to uh, okay, actually this is only fine. You have to exclude the case basically when nothing is selected, right?
Yeah.
From the total number of ways to do these selections, you have to exclude the thing where nothing is selected, right? So you can think of it in this way. Let's say there are n things, right? A1, A2, AN, right?
Yeah.
And you have to select one or more than one out of these, right?
Yeah.
We got the answer already in a different way, right? NC1 plus NC2 and so on, right?
Yeah. Yeah.
And we got 2 power n minus 1. Now let's look at an alternate way to think about this. So think of each object, right? Think in terms of the object. Think of each object, and as you, the person, are going to make a decision, what can you do? You can either select the object or reject the object, right?
Yeah.
For each object, you as a person has how many choices, right?
Yeah. 2.
You have two choices, no?
Yeah.
This two choices, right? And notice that in order to make a complete selection, you have to make a decision about each of the objects, right?
Yeah. Yeah.
See, a particular selection is not complete until you have decided what to do about each of the objects, right? Whether it is there or whether it is not there, right? So in your selection, if I have, for example, selected A3, A5, and A8, right? That means I have rejected A1, A2, A4, A6, and so on, right?
Yeah, yeah,
So a selection means I have selected these three and rejected the rest, right?
Yeah.
And this is one possible instance of the NC3 ways in which you could have selected three, right?
yeah,
You
Yeah.
understand?
yeah, yeah.
Yeah.
So since you have to make the decision about each of the n items, only then your one selection is over, right? Then this is like breaking down one selection into n sub decisions, right?
Yeah,
So
Yeah.
this is a and problem, no? You have to decide what to do about the first one and the second one
and
and the nth one, right? Only
mm,
then you know
Yeah.
whether the selection can be done or not, right? Correct.
yeah,
Yeah.
So total number of ways of making a selection is what? 2 into 2 into 2 into, right?
yeah, yeah,
Mm.
Total number of ways of making any selection is this, right?
Yeah.
yeah, yeah,
However, this will include a case where you have rejected every one of them, right?
yeah, yeah,
This
Yeah.
will
Yeah.
include a case where you rejected first one, second one till nth one, right? There will be one such case, right? One case
yeah,
where you
Yeah.
yeah,
rejected all.
yeah.
So that will not be in our current thing because you have to select one at least, right?
One, yeah.
So
Mm.
total
Yeah.
number of ways should be 2 power n minus 1, right?
Yeah,
Yeah.
You understand that it's a very different way to do the same thing.
yeah, yeah,
Correct. Everyone is getting that,
Yeah.
no?
Yeah.
yeah,
Yeah.
This was
yeah,
the direct way to do it, how to select one, two, so on, right? And this was a different way to think of. Right now, we are thinking of how to do any selection. You have to make a decision on n items, right? Each item
Mm.
can be either selected or rejected. So 2 into 2 into 2, these are the total number of ways to make a selection, right?
yeah,
Which comes out to
Yeah.
be 2 power n. Out of this, there is one selection where you have rejected everything. 2 power n minus 1 will be the number of selections where you at least select one object or maybe possibly more, right?
yeah, yeah.
Yeah. Yeah.
Okay. So that is clear. Then, uh, fine. Now let's look at, these were all fine because these were all questions where the number of articles were different, right? Correct. Now the question is the total number of ways of selecting one or more things, of selecting one or more things from from p identical things of one type, q identical things of another type, of another type, are identical things of a third type, and so on. Identical things of a third type, a third type, and n distinct things.
Okay.
Okay. So what you have right now is you have the total number of things available to you are what? There are p things of one type, right? So
Yeah.
let's say these are PAs, right? P.
Yeah,
Mm.
And then
Yeah.
there are Q things of another type, right?
yeah,
There are QBs, okay? There are
Mm.
R things of another type. There are RCs, right? And after
yeah,
that, there are N other letters,
yeah,
N
Mm.
distinct things, right?
yeah,
Yeah. Yeah.
And what you have to do is find out the total number of ways of selecting one or more things from them, right?
yeah,
Yeah.
yeah,
One or more, like you could select just one, or you could select two, or you could select three, and so on, right?
Yeah.
Yeah.
From how many total things are there? Actually, total number of things are n distinct things plus p plus q plus r,
Yeah.
right?
Yeah. Yeah.
These are the total number of things, right?
Mm.
Yes. Yeah.
So let's try to figure out this one. So think in separate batches, like think for here, right? If they're
Mm.
identical things, right?
Yeah.
The number of ways of selecting one thing out of this is how much? One.
One. Yeah.
Two things out of this? One way.
One. Yeah.
Yeah. Yeah.
P things out of this? One way, right?
One way.
One way.
Yeah.
Yeah.
Right? So basically, the number of ways of selecting one to p things out of these things is all going to be one, no?
Yeah.
Yeah.
Right? So what are the options that you have? You can select one thing, you can select two things, you can select three things, and you can
Mm.
select p things, right?
Yeah.
Yeah.
And
Yeah.
each number of ways there is p one, right?
Yeah.
So total number of ways selecting one, say selecting 0 or 0 to p, 0 to p things, right?
Mm.
See how many ways of selecting nothing out of this? That is also one, no?
Yeah.
Yeah. Yeah.
And selecting one thing out of this is also one, and two things is
Yeah.
also one, till p is also one, right?
Mm. Mm.
So number of ways of selecting one or 0 or more things out of this will be 1 plus how many times from 0 to p, right? So p plus 1, right?
Mm.
Yeah. Yeah.
There are p plus 1 ways of selecting 0 or more things out of this this batch, right? Of
Yeah.
identical
Yeah.
p things, right?
Yeah.
Similarly, here there will be q plus 1 ways of selecting 0 or more from here, right?
Yeah.
Because
Yeah.
you could
Yeah.
either select 1 or 2 or 3 or 0 or q, right?
Mm. Yeah.
And
Hmm.
each selection can be done in one way, right?
Yeah.
And
Yeah.
similarly, there will be r plus 1 ways of doing this selection, right?
Mm.
Correct?
Yeah.
Yeah. Yeah.
From 0 to r, right? But for this part, the number of ways of selecting will be 2 into 2 into 2 into 2, right?
Yeah. Yeah.
You have to make a selection or a rejection decision, right? And
Yeah.
for each object you have two possible choices, right?
Mm.
So it will be
Yeah.
2 power n here, no?
Yeah.
Yeah. Yeah.
So what we have calculated is the total number of ways of selecting 0 or more things out of these things, right? Will be p
Mm.
plus 1 into q plus 1 into r plus 1 into 2 power n, right?
Yeah. Yeah.
Yeah. Yeah.
However, that includes the case where you have rejected, you have selected 0 from here, 0 from here, 0 from here, 0 from here, right?
Yeah.
So
Yeah.
subtract 1 from it.
One minus.
So the total number of ways of doing this would have been p plus 1, q plus 1, r plus 1, 2 power n minus 1. Number of
Mm.
ways of selecting one or more things out of p identical, q
You are.
identical, r identical, and n distinct
Mm.
things, right?
Yeah.
Yeah.
These are p identical of first type, and this is second type, and this is third type, and so on, right?
Mm.
Correct?
Yeah.
Yeah.
Because you could have done this in p plus 1 ways to select 0
Yeah. Yeah.
or p things from here, right?
Mm. Yeah.
and
Hmm. Yeah.
and you have to do the whole selection process for all types of things, then only you make a complete selection, right?
Yeah.
No matter how
Yeah. Yeah.
many things you are selecting, you have to decide whether to reject or select some everything, right?
Yeah. Yeah.
And here you are including a case where you have rejected everything, so you
Yeah.
subtract that, right?
Hmm.
Hmm.
So let's see an example of this. So question is, how many ways can one, in how many ways can one or more fruits be selected out of a basket, be selected out of a basket that has four identical apples, five identical bananas, five
Hmm.
identical bananas, and three other distinct fruits,
Hmm. Hmm.
right?
Yeah.
Yeah.
One or more fruits have to be selected from that basket. How many different ways can you do it? There are four identical apples, five identical bananas, and three other distinct fruits.
Hmm.
Hmm. Yeah. Yeah.
Hmm.
So this is a real type of question which can be asked on this, right?
Yeah.
So
Yeah.
now
Yeah.
four identical banana apples you can select in five
Five.
ways, right?
Two
5 ways. Yeah.
39.
And this would be six ways, right?
Yeah.
Yeah.
And
239.
Then 8.
2 power 3
Yeah.
minus 1,
Yeah.
Minus
right?
Yeah.
1.
-1.
240 minus.
Okay. So this will be 240 minus 1, so 239 ways.
Yeah.
So
Yeah.
which is
Yeah.
quite high if you see, right? This is
Yeah.
like
Hmm.
if I had done this question in the different way, no, it would have been a little more annoying.
Hmm.
You
Hmm.
understand?
Yeah.
You don't know first of all how many to select, right?
Yeah.
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 The total number of things are actually 9 plus 3, you can go up to 12, right?
Yeah. Yeah.
12 fruits are there, no? So now
Hmm.
1, 2, 3, 4. If I try to do it in the more straightforward way, no? Like you have
Hmm.
options of selecting one fruit, two fruit till 12 fruits, right?
Yeah.
Yeah. Yeah.
So then one fruit could have been selected from any one, right?
Yeah.
So
Hmm.
there are
Yeah.
how
Yeah.
many ways to do that? There are 12 ways then, right?
Hmm.
Yeah.
Right?
Yeah.
12
Yeah.
ways. Two fruit could have been selected in multiple ways now, right?
Hmm.
There are many
Hmm.
options now, right?
Hmm.
You
Hmm.
could have selected two from this, right? That could have been 3C2.
Yeah.
You could have selected two from here. That could have been one way, or two from here. That could have been one way.
Yeah.
Then there could have been a mix, right? One from here, one from here.
Yeah. Yeah.
That would
Yeah.
have
Yeah.
been one way again.
One way.
And there could
One.
have been
Yeah.
one from here and one from here, right? That could have
Hmm.
been three ways, right?
Three ways.
3 ways.
You
Yes. Yeah.
understand? And one from
Yeah.
here and one from here, again three
Again,
ways.
3 ways.
3 ways.
And two, is there any other way? I don't think so now,
No.
No.
right? So this is the number of ways to select two fruits, right?
Hmm. Yeah.
So this 3C2 is 3, so 9 and 3. Okay, again 12, right?
Hmm.
However, things will change when it becomes 3, 4, 5, 6, and all, right?
Yeah.
Yeah.
You
Yeah.
understand? This will become too complicated to do because there are too
Hmm.
many cases,
Yeah.
right?
Yeah.
So
Yeah.
Yeah.
the better way to do it is by thinking of selecting all possible ways to select and then subtracting the way in which you are rejecting everything,
Hmm.
right?
Yeah.
All
Yeah.
possible ways to select. No, basically, don't think in terms of how many fruits you are selecting. Think in terms of what happens to each fruit. Are we rejecting it or selecting it?
Yeah. Yeah.
Think in terms of your selection rather than which fruits are how many, right?
Hmm.
Hmm.
You
Yeah.
understand?
Yeah. Yeah.
Like this is a different approach to the same question. No? We are not doing NC1 plus NC2, that type of thing,
Yeah.
right?
Yeah.
So
Yeah.
think in terms of your overall selection and how can you build an overall selection rather than how many I have to select from where.
Yeah.
Okay. So now this idea can help us do things like uh, find the number of factors. Find the number of factors of n is equal to 2 power p, 3 power q, 5 power r, and so on, right?
Mhm.
Find the total number of factors of this integer where you have written the prime factorization like this, right? Correct.
Yeah.
Yeah.
So let's think about how we will go about doing this. So the number of factors obviously has to be, it could be 0 or 1 and all, right?
Yeah.
Like 2 power p means there are two powers could be from here 0 to p, right?
Yeah. Yeah.
In
Yeah.
any factor, the power has to be from 0 to p, it cannot be higher,
Yeah.
right? And each of the twos are basically this is like there's a basket of twos, right?
Yeah.
And there's a basket of threes, and these are
Mm-hmm.
p twos and q threes and 5 and r fives, right?
Yeah.
Yeah.
And you have to select to form a factor, you have to select prime numbers from here in these baskets,
Yeah.
and 0 or more, right?
Mm-hmm.
You can take 0 or more, actually all possible factors you have to count, right?
Yeah.
You can do this selection
Yeah.
in p plus 1 ways, no?
Yeah.
Either don't select a 2 or select 1 or 2 or 3 or p twos, right?
Yeah.
Which is
Yeah.
p
Yeah.
plus 1 and this
Yeah.
is q plus 1 and this is r plus 1 and so on, right?
Yeah.
For other
Yeah.
prime factors,
Yeah. Yeah.
right? So the total number of factors will simply be the product of these, right?
Yeah.
Each
Yeah.
factor is going to be a selection of the exponent of the prime factor, right? Prime number, right?
Yeah.
So,
Yeah.
so
Yeah.
it will be p plus 1 into q plus 1 into r plus 1 and so on. No?
Yeah.
This will include a factor where you have rejected all the prime numbers, right?
Yeah.
Basically 1.
Yeah. Yeah.
One.
1
Yeah.
is included in this. Also, it will also include n,
And
right?
all of them.
So if you want some proper factors or stuff, you can subtract these, right?
Yeah.
Mm.
Correct.
Yeah. Yeah.
So that is the total number of factors, right?
Hmm.
Uh, so okay, so for example, one question is find the number of even factors of 2 cube, 3 square, 5 cube, 7 power 4. Are you understanding? For even factors, you have to keep at least 1, 2, right?
Yeah.
Yeah. Yeah.
You cannot have 2 power 0. You can have 2 power 1, 2 power 2, 2 power 3, right?
Yeah.
So instead of 4 values here, you have only 3 possible
3.
ways, right?
Three. Yeah.
And the
Yeah.
rest will be 2 plus 1.
180.
180.
Yeah.
Rest can be anything, right? As long as you have
Yeah.
ensured this, right?
Yeah. Yeah. Yes, yeah.
So this will be just simply 3 into 3 into 4 into 5.
Yeah.
Ah,
So 20 into 9, 180.
180.
yeah.
Yeah.
Now you could have asked the same question. You could have asked the number of factors which end with 0.
Hmm.
Find number of factors which end with 0.
Hmm. 135.
Correct, because to end with 0, you have to be divisible by 10.
Yeah.
Divisible
Ah, yeah,
by
yeah.
10, that means you have to have 2 power 1 and 5 power 1 at least, right?
Yeah.
Yeah, yeah.
So 2 power 0 cannot be there, 5 power 0 cannot be there, right?
Yeah.
So you have
Yeah.
basically 3 into 3 can be anything, so 3, and 5 cannot be 4, it can be only 3, right?
3. Yeah.
And
And
Yes,
this
then,
yeah.
can be 5, right?
yeah.
Yeah.
This is 27 into 5, which is 135.
Hmm.
Yeah.
So understand that here we are picking out number of ways to pick out some n things out of identical things, right? Groups of
Hmm.
identical things, correct? So this
Yeah.
was different from picking out r things from n different things, right?
Yeah.
Mm-hmm.
Right. So uh, just recognize the difference between the things that we are doing, right?
Hmm.
So let's look at some more examples. Hmm, okay. One second. Just hold on. Okay. Uh, question: in how many ways a playing 11 can be selected from 15 players,
Hmm.
from 15 players, if out of 15 players 2 players can play only as a wicket keeper, if out of the 15 2 players
Hmm.
can play only as the wicket keeper. Yes, wicket keeper. Basically, in the 11, you can only have one wicket keeper.
Yeah.
That is the rule. Okay. So only
Yeah.
one out of the two can be the wicket keeper. And then you have to tell me how many ways of selecting that playing 11, right?
Hmm.
So 13 are normal players, right?
Yeah.
Yeah, yeah.
So out of the two wicket keepers, selecting one wicket keeper will be done in how many ways?
What?
Out
One.
of the two wicket
One.
keepers, you can select one wicket keeper. No, these are not identical. No,
Ah, two ways. Yeah.
these are people, dude.
Yeah, yeah, yeah.
They are not identical.
Two ways. Yeah.
2C1,
2 ways, yeah.
right?
Yeah.
2C1.
Yeah.
Right, which is 2, right?
Yeah.
And after that, you have to select the remaining team also. There are 13C10, no?
Yeah. Yeah.
You
13 seat.
understand that this is not the identical case, no? You are selecting people.
Mm-hmm. Yeah.
Yeah,
So you
yeah.
have to be careful about identical or distinct, right?
Mm.
So 2C1
Yeah.
into 13C10 will be the answer here, right?
Yeah. So
Okay,
5,
don't have to
7,
calculate,
2.
it's fine. Uh, Next one is committee of 3 men and 3 women. 3 men and 3 women committee has to be formed from 6 men and 7 women. From 6 men and 7 women. How many ways can we do this? Just the expression is also fine.
Mm. Mm.
How many ways can we select 3 men from the 6 men?
6 seat 3 and
6.
then 2,
Yeah.
6, 7 seat 3.
7C3. Yeah.
Right?
Yeah.
This is the total number of ways of selecting this committee, right?
Yeah.
Yeah.
Suppose the same question is there, but one person, one man is always selected. If one man is always selected and one woman is always rejected,
Mm-hmm.
and one woman is always rejected, so then how many ways to select the committee?
5 seat 2 into 6 seat 3.
5C2, because one person, one man is always selected. So out of 5, you have to select 2.
Yeah.
Multiplied
6 seat
by
3.
one woman is excluded, so 6C3. Correct. Does it make sense so far?
Yeah.
Yeah.
Okay. Then the next one is there are n stations on a railway line. On a rail line. Okay. If the number of types of tickets printed on a one-way journey, if the number of different tickets printed on a one-way journey,
Mm.
basically one-way journey is one direction, right? Is 210. Find the number of stations. Are you understanding how each ticket will be different?
Yeah.
Right. So if the
Sir, I'm
two,
a bit confused.
okay. So how does a railway line work? There is station 1. This is Kormangla. And there is HSR.
Okay.
If we had a metro station, then this is what it would be like. This is HSR. Then there is Sarjapur and Belandur and all.
Yeah.
suppose. And then there is Marthalie, and then there is Whitefield, and whatever. Okay.
Mm.
Yeah, okay.
So suppose you are going in this direction one way. How many
Yeah.
tickets will be printed? Which type of tickets? Kormangla to HSI is one ticket, right?
Yeah.
Yeah, yeah.
Kormangla to Sarjapur is a different ticket.
Yeah.
HSR to Sarjapur is a different ticket. HSR to Barandur is a different ticket, right?
Yeah. Yeah.
Yeah,
These
yeah.
are all different tickets. You only can go
Yes.
one way. So all the possible different tickets, the total number is 210,
Hmm.
right?
Mm.
Yeah.
How many such stations are there, right?
Yeah.
Yeah.
So how many total number of such tickets can be made? Basically, is the question.
Mm.
So how many stations does it take to make one ticket, right? Two stations. You have
Two
to know
stations.
both the
Yeah.
stations, right? Starting point and end point.
Yeah.
Yeah.
Then only you will get a unique ticket, right?
Yeah.
Yeah, yeah.
So out of n stations, select any. How many ways to select two out of n, right?
Mm.
Any different,
Yeah.
any selection
Yeah.
of these two will be different. No,
Yeah. Yeah.
are you
Yeah, yeah.
understanding? You have to select
Yeah.
a pair of stations from this, right?
Mm.
And
Yeah.
that will give a proper unique ticket.
Yeah.
It is not an
Yes.
ordered pair because that would mean two-way trips, right?
Yeah. Yeah.
If the order mattered, it would be have two-way trip,
Two
right?
way trips. Okay.
So
Yeah,
if it
yeah.
is a one-way trip, you just have to do NC2, right?
Yeah.
NC2 is equal to 210, right?
Yeah.
Select any two stations out of these, you will get a unique ticket.
Mm.
So NC2 is 210 will become n into n minus 1 by 2 is equal to 210. So n into
Yeah.
n minus 1 is equal to 420, right?
Yeah. Yeah.
So
Yeah, yeah.
so this can be done. So 14 into 30, so 28 into no. So
21
14,
into 20.
21 into 20 works,
Yeah.
right? N is
Yeah.
21, right?
Yeah.
Makes sense.
Yeah. Yeah.
Yeah, yeah.
Next question is, uh, next question is this one. In a party, 10 students, 10 students gave gifts to each other.
Mm.
Gave gifts to each other. Okay.
Yeah.
Find the total number of gifts.
So
So
one person gives a gift to only one other person, or like all the line.
no, what does the sentence mean? See, 10 students
So,
gave gifts to each other. No.
Huh.
So everyone gave gift to everyone else, right?
Okay. Okay.
Right.
Yeah.
Because all that it's not like I will give only gift to one person and rest of the friends I'll ignore. Right.
Yeah.
I mean you can do that, but that will be sad.
is it 100?
Why 100? How?
Because there are 10 students and each has 10 gifts,
How
like
10
for each.
gifts?
Oh yeah,
9, no?
9. 9. Yeah.
9 gifts.
Uh,
90.
no, but be careful a little. It's not necessary that you might have double counted or something, I think. Just be a little careful. Do the question for a small number. Do the question for 4 people or 3 people, right?
Mhm.
Then you will realize what is happening. Oh, it is answer is actually 90. Yeah.
Yeah.
But the way to think about it is, suppose there are 10 students, right?
Yeah.
Yeah, yeah.
J, till Hij, right?
Hmm.
Correct.
Yeah.
So each person gives a gift to each other, right? They're giving gift to everyone. Right? One way to do it is how you did it. Is every person has nine other people, right?
Yeah.
Yeah, yeah.
So nine, and the second one also gives nine. So total number of gifts should be 90, right?
Yeah.
One
Yeah.
more
Hmm.
way to think about it would have been make all the possible pairs, right? Out of these 10, right?
Hmm.
How many
Yeah, yeah.
pairs are possible? 10 C2.
Yeah. Yeah.
And each pair will give two gifts, right?
Two gifts.
One
Yeah.
person will give to the other and that person will give to him, right?
Hmm.
So
Yeah.
make all
Yeah,
possible
yeah.
pairs into two gifts per pair, right?
Hmm. Yeah.
So that will also be 90,
Hmm.
Yeah, okay.
right?
Yeah.
Okay. Then let's look at some more examples. Hmm. So there are six questions in an exam. Six questions in an exam.
Hmm.
Uh, a student has to answer. Student has to answer at least three. Has to answer at least three questions to pass. At least three to pass.
Hmm.
To pass. Now, how many ways can the student fail the exam?
Uh,
Are you understanding the question?
Yeah,
Hmm.
yeah.
Hmm.
He has to answer at
Sir,
least
is it
three to pass.
17?
Wait, let me see once.
I got 22.
Oh,
1 second. It should be 22, no?
Yeah.
See, he can fail if he answers 0, 1, or 2,
Yeah.
right?
So
yeah, yeah.
62 plus 61 and 15, 6 and 1.
Right? You thought 62 is 10, I think. That is your mistake.
Okay, yeah,
62 is
maybe.
15. And this is 6, and this is 1.
Oh, yeah. Calculation error.
Right? This is 62, right? So
Yeah,
6
yeah.
Yeah.
into 5 by 2.
50.
5C2 is 10, not 62.
Yeah,
Hmm.
yeah.
Hmm.
Okay. Then see, you if you get 0 or 1 or 2, you can fail. No, so these are the total
Yeah.
ways to fail,
Yeah, yeah.
right? Total ways to
Yes.
write the exam would be how much? Like pass fail doesn't matter. How many ways can a student write that exam?
6C3
Plus 64 and
plus 634 plus
another 65,
635.
66.
So total
All
ways 2
together.
par 6.
Yeah. Hmm.
Why am I saying 2 par 6 so quickly? I have not added 6C0 to 6C6. I have said
Mhm.
that each question can be done or not done.
Yeah.
There are
Yeah.
Okay.
6
Yeah.
questions, right?
Yeah. Yeah.
So number of ways to do the exam is to decide whether to do or not do each question, right?
Yeah.
So
Hmm.
two options for each question. So 2 power 6 total number of ways, right?
Yeah. Yeah.
Yeah. Yeah.
So 64 ways of totally doing that exam, either passing or failing, right?
Hmm.
Out of
Hmm.
which number of ways of failing are how many? 22, right?
22. Yeah.
So there
Yeah.
are 42 ways to pass,
Yeah.
Yeah. Yeah.
right? And
Yeah.
22 ways to fail. Are you understanding?
42 is what you get when you take 63, 64, 65, and
Uh,
66, right?
the addition of 63, 64, 65, 66 should be 42.
Okay.
Hmm. Yeah.
Is it making sense?
Yeah.
Yeah.
But I
Yeah.
can get that in a faster way. I don't need to add it. If it was some
Hmm.
big numbers, it would have been annoying to add.
Yeah. Yeah.
I could have gotten it by this, right?
Hmm.
Okay. Then let x be the number of factors of 2000, and y is the number of factors of 3000, and z is the number of common factors of 2000 and 3000, right? Find
Yeah.
x minus z by y minus z. Number of factors x and y can be easily calculated.
Yeah. Yeah.
So 2000 is what? 2 power 4 into 5 power 3, right?
Hmm.
125 into 16 will be 2000. And this
Yeah.
is 2 power 3 into
3 and
3 power
hmm,
1 into 5 power
5 by
3.
3. Yeah.
Okay. You can do the
Yeah.
calculation and check. 125 into 8 into 3, right?
Yeah. Yeah.
Yeah.
So number of factors of this is how many total number of factors are? 4 plus 1 into 3 plus 1, no?
Yeah.
Yeah.
So
Yeah.
20 and 32.
So 20 factors here, and number of factors here is 3 plus 1 into 2, 4 into 2,
4 into
8
2 into
into
4.
32 factors here, right?
Yeah.
Yeah.
Now the problem is that I don't know how to find total number of common factors though.
One will be like we can take 2 cube and 5 cube.
Correct.
That's
So
the only two prime.
see, can a common factor have 3 in it?
No.
No, right? Because there is no
No.
3 in this, right?
Hmm.
Yeah.
So let's find a highest common factor first, no?
Hmm.
Yeah.
HCF, right?
Yeah.
HCF will be simply 2 power 3 into 5 power 3, right?
Yeah.
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 Correct. So there
Yeah.
cannot be any other common factor which is higher than this, right?
Yeah.
And a
Hmm.
common factor cannot have 3 also, right?
Yeah.
Yeah.
So the number of common factors will be 2 ka lower powers and 5 lower powers
Yeah.
up to
Yeah.
3, right?
Yeah.
So 4 into 4,
4
right?
Yeah.
into
Yeah.
4, 60.
16 common factors.
Yeah. So,
Because you know highest common factor is this, right?
hmm. Yeah.
So now it is very easy. Now it's over. It is 20 minus 16 by 32
32
minus
by
16.
4.
So 4 by 16. So 1 by 4.
Hmm.
Correct?
Yeah.
Yeah.
Okay. Then let's look at some other questions also. The reason we are doing so many questions is because it is easy to get confused here unless you practice enough questions, no? It is very easy to
Yeah.
get confused in all of this. So what we are doing is doing enough questions that this whole thing will be okay.
Mm.
Yeah.
It will take some time, but it is important to get it sorted once and for all, rather than like keep getting confused in this chapter. Like when I
Yeah.
was studying, I used to face a lot of issues in this chapter because there were no nice books which were explaining it properly. Like it was really hard. It was because the type of questions that you get can be like very similar yet different, right?
Yeah.
This is
Yeah.
a little bit of imagination and stuff is required here.
Yeah. Yeah.
So let's see. Uh, uh, okay, I mean, there are some similar stuff. I want to look at something unique. One second. Mm, okay. Given 5 different mm, green dyes, 4 different blue dyes, 4 different blue dyes, and 3 different red dyes. 3 different red dyes. How many combinations of dyes can be chosen? How many combinations of dyes can be chosen such that we have at least one green and one blue is there. One green dye and one blue dye is present. How many combinations of dyes can be chosen such that one green and one blue is present? It is the same idea that we have seen earlier.
Yeah.
5 different, these are different, right? So
Yeah. Yeah.
5 different dyes as that one green. So basically you have to select 1 or 2 or 3 till 5, right?
Yeah. Yeah.
For the
Yeah.
green ones, right?
Hmm.
So that will simply be 2 power 5 minus 1, right?
Yeah. Yeah.
You
Yeah.
are excluding the case where none of the green ones were selected. Or basically you
Yeah.
are saying 5C1 plus 5C2 till 5C5, right?
Yeah.
Yeah. Yeah.
And 4 different blue dyes are selected. So there is one restriction on blue dye also, right?
Yeah. Two
So
power
it will be
four minus one.
4C1 plus 4C4, right? 2
Hmm.
power
Mm.
4 minus 1. And there is no restriction on the red dyes, right? That
Yeah.
would simply
Yeah.
be 2 power 3, right? 3C0 plus 3C1 plus 3C2 plus 3C3, right?
Yeah. Yeah.
Yeah. Yeah.
But you have to make a selection. How many combinations of dyes can be chosen, right? Such that one, this is okay. So it should be multiplication now, right?
Yeah.
Yeah.
Multiplication.
Correct.
Yeah. Yeah.
So
Yeah.
31 into 15 into 8, right?
Hmm.
That should be the number of ways in which you can choose a combination of dyes.
Okay.
Does it make sense? Why is it
Yeah.
multiplication? Because you have to choose this and this and this, right?
Yeah. Yeah.
Yeah.
It's
Yeah.
an and problem. It's not a or problem, right?
Yeah,
Yeah.
yeah,
So
yeah.
it's multiplication. Okay.
Hmm.
Is
Yeah,
it making sense for everyone?
yeah, yeah.
Yeah. Yeah.
Okay. Uh, then let's go to mm, okay. Question is, consider a set. Consider a set S with n elements
Mhm.
with n elements which are labeled like this: A1, A2 till AN. Okay.
Hmm.
What is the number of subsets? What is the number of subsets of this set? Number of subsets of S which contain odd number of elements. Which contain odd number of elements. Okay. So before you can do that, can you tell me how many total subsets are there?
We,
Huh?
we can take a subset with nothing also.
Subset can be nothing also. Null set is also a subset, and the full set
Yeah,
is also a subset.
so it'll be just too far.
2 power n, right?
Yeah.
Yeah. Yeah.
This is there in sets, relations, and functions in your 11th standard NCRT,
Mhm.
right? Total number of subsets will be 2 power n. The reason is obvious. You can make a choice for A1, A2, AN, right?
Yeah.
Yeah.
And you can decide whether A1 is going to be part of your subset or not.
Or not. Yeah.
Hmm.
You can either select A1 or not select A1, right? So
Yeah.
while constructing any subset, for you, the choices are pretty clear. It is two choices for each element, right?
Yeah.
So 2 power n
Yeah.
total
Yeah.
choices for constructing your subset, right?
Yeah.
Which will include the cases where nothing was selected and all of them were selected.
Hmm. Yeah.
So this is total number of subsets. But now you have to find the number of subsets which have odd number of elements, right?
Yeah.
Hmm. Yeah.
So basically it's like n, out of n you have to select 1, or you have to select 3, or you have to select 5 until the last odd number, right?
Yeah.
So depending on if n is even, you
And
have to go to n minus 1. If n is odd, you have to go till NCN,
and
right?
yeah.
Correct?
Yeah. Yeah.
Yeah.
So this summation you should be able to do because you know binomial theory.
Hmm. Hmm.
We have done this in the binomial theorem discussion. We saw no that this one was just the odd ones, right? Summation.
Yeah. Yeah.
Yeah.
This was equal to even ones, right?
Yeah.
Which was equal to 2 power n
Super
minus
and
1.
minus.
Yeah. Yeah.
How did it come equal to the even ones? You put 1 and minus 1 and you put for 1 plus x, right?
Yeah.
Hmm.
Yeah.
Hmm. Yeah.
In 1 plus x power n is equal to c0 to c1x plus
One and
c2x
minus
square.
one.
Put 1 and minus 1, right?
Yeah.
You'll get 2 power n is equal to sum of all of them, and 0 is equal to sum of alternate signs.
Yeah. Yeah.
Yeah. Yeah.
Correct?
Yeah.
So you can prove from these two that all the odd ones addition will be 2 power n minus 1, right?
Hmm. Hmm. Yeah.
Hmm.
So the answer for this should be 2 power n minus 1.
Hmm.
Correct?
Yeah.
Yeah.
Okay. Fine. Okay, we'll stop here. What
Mhm.
we will continue from next classes, we'll do more theory. I will try and send you some sheets and all for this. And basically, we are doing right now selections. Okay, so
Yeah.
there are quite a few things here. So I don't want to do everything on one day. So right now, whatever we learned today should be clear.
Yeah.
And next class, we
Yeah.
will continue from here and go to slightly harder questions and different ideas. Okay.
Okay.
Yeah.
Fine. Yeah. Tomorrow we can do chemistry whenever we decided something. No,
4 o'clock.
4 o'clock. Yeah. If
Mm.
4 o'clock
Is
is fine,
3:30 okay? Like
Yeah,
for
that's
you?
for
I'm
me
fine
it's
with
fine.
that also.
3:30 is also fine for me. So Bhavesh can
Then can
message
we
on
do
the
a
group.
3:30?
Yeah, yeah.
Because like
1 second. Let's just check with Bhavesh also. So he can message on the group if it is fine for him. Okay.
Yeah.
Okay. So it's fine for him. So then we can do it at 3:30. That's not a problem. Uh,
Mm.
Also, Bhavesh, I have sent your parents some message. Just let them confirm with them, right? If they got it, just check with them. I sent a mail and a message. Okay. Okay. That's all for now.
Yeah.
Uh,
Okay.
we'll see tomorrow for chemistry.
Yeah.
Chemistry, we were
okay,
doing
sir.
that last part, no? The acids and bases part we have to do, and we have to know,
Yeah. Ionic equilibrium.
right?
Hmm.
So what is going on in class for you guys right now?
Ionic only they started.
Yeah.
Okay, fine. So we'll continue with that. This is the last thing that we'll be doing before we start organic. So in Jan, we'll be starting organic. Okay.
Okay. Yeah.
So I have sent the book, by the way, right?
Yeah. Yeah.
The name of the
Yeah.
book I have sent, so you guys can buy that book and
Mm.
the Claydon Greaves
Yes.
book.
Yeah.
Okay.
Yeah.
And there is a problem book for that which I have sent PDF. Don't need to buy that one.
Okay.
Uh,
Yeah.
we'll be using that on for questions, and we'll be using this book for text as a textbook. Okay.
Okay.
Yeah.
So it is important because it will take some time to do the whole thing. You need to study from a proper textbook here.
Mm.
So
Mm.
it is a very nice book. So just buy it and
Yeah.
we'll start that in Jan. Anyway, I'll see you tomorrow.
Yeah. Yeah.
Okay.
Bye,
Bye.
sir.
Bye. Sam.